often like responding to challenges from flat earthers, and there's been a few of them over the years, like this £10,000 challenge from flat earther Calvin Stroud.
So people say put your money where your mouth is.
Oh, here we go.
There's my money, right next to my mouth.
Good one. And this one from the Flat Earth Millionaire.
You know, observing, measuring, and repeating water sticking to a ball. You know, it didn't even have to be spinning. We just want to see water conforming to the exterior of a ball.
Okay, shouldn't be too difficult. Here we go. And today I'm going to respond to another one. Now, there's no prize for this one, but it is a challenge all the same, apparently. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Anthony Bear is a flat earther who seems to think he can challenge us on the River Nile. Please don't tell me that because it flows north, he thinks it won't work. Let's find out.
So I was talking to a friend of mine and I was like, can you take the Nile River and put it on a globe and actually make it function?
Funnily enough, it functions quite well, thank you, because it exists and it functions.
This guy's like a PhD, like electrical engineer. You know what I'm talking about. So he says, of course I can. I'm like, whatever, dude. So I decided to give him a head start. Okay, here's a topographical profile of the Nile River. Here's Lake Victoria. It drains down into the Mediterranean Sea.
And that right there should be all you need to know. The topographical profile clearly shows there's a downhill trend as the River Nile goes from the source to sea.
It's 1,135 meters high, so it's about 3/4 of a mile high. And it's 4,200 miles long. So it goes from 3/4 mile high to 4,200 miles. Okay, let's check out the Nile River on a globe. So here's Lake Victoria. It flows north all the way to the Mediterranean Sea. So it goes from here to here.
Yes, what's the problem? Although I worry that I already know what the problem is. Let's continue.
So let's check it out from the side view. Okay, here's a little mock-up of the Nile River. To make it accurate on a globe like this, it needs to be 0.08 of an inch thick. But for demonstration purposes, we'll just make it something I can actually hold in my hand.
So totally not to scale then. Okay, great, gotcha.
So let's lay it down across like that. And let me show you the top view. Okay, we're back to the side view. All right, the Nile River travels north from Lake Victoria to the Mediterranean Sea. It zigzags 4,200 miles, but it travels 2,400 miles. Okay, let's do the math. Here's Google Earth. You can see it travels 2,348 miles. Let's check out the Earth Curvature calculator.
Oh, he's not doing this, is he? Please tell me he's not.
We're going to type in a zero viewing height and then the distance of 2,348 miles, just like Google Earth says.
Now, before he continues, obviously we don't expect to see the mouth of the Nile from its source. So I'm not really sure what he's going to try and prove here.
And our Earth curvature is 3,399,986 feet. Not bad. Now we take our Earth curvature in feet, divided by 5,280, and we get miles, 643 miles. Now we divide it by 2, and we get 321 miles. Okay, back to the side view. Okay, so the Nile River, if you lay it flat on the globe, it would be a 300 and some mile hump in the middle.
Now this is not how the curve calculator works, buddy. The curve calculator is explicitly used for calculating how much curve is hidden based on distance to something and the viewer height. Now yes, technically there is an earth bulge in the middle of the Nile, but the Nile is on that bulge. You can literally see it in your video. Look, this little yellow line is your bulge and the Nile is on it.
That's higher than the International Space Station. Obviously, it can't go over this hump, the 300-mile hump, because gravity goes this way, right? Gravity doesn't go this way. It goes down this way.
But the hump isn't on top of Earth's surface. Earth's surface is the hump.
By the way, gravity is not a downward force. It's a bending of space-time,
which manifests itself here on Earth as a downward force.
Just like you guys are going to bend what the hell I'm saying after this video. I make this video. Let's do another example. Here's this ship, right?
Oh my days.
Downward force. It doesn't blow the ship right off the planet, does it? Obviously, it can't go over a 300-mile hump. So, let's flatten it out like the topographical profile. Okay, we flatten out the Nile River. The Nile River only pitches 1 mile down. So, in fact, the last 1,000 miles of the Nile River only pitches 100 feet. So basically, we're going to lay our Nile River on top of the globe. And you can see it's floating up in the air on each end 300 miles.
So you've just proven then that the Earth itself is the bulge. And the topographical profile is the distance above sea level, which aligns itself with the surface of the Earth, no matter what shape that is.
Do you know of anything that sticks up on the Earth 300 miles? I don't think so.
No, because that is not how rivers work in reality. Here's a picture of the Nile from the ISS. That looks like it works pretty well to me.
Higher than a space shuttle? No. All right, so now let's pitch it so it actually drains into the Mediterranean Sea. Okay, that's awesome. Uh-oh. The one side is up like an inch.
I think scale is something that's completely lost on flirts, isn't it?
An inch on this globe is like more than 1,000 miles up. I don't think there's any mountains that are 1,000 miles high on the Earth anywhere. All right, so now if we lay it down flat, let's say we're going to shove it into the globe. And let's see what happens. Okay, here's our soft globe. See, it's sticking up 300 miles. All right, let's shove it into the globe. If we shove it into the globe and make it level where it pitches this way a mile, it's going to fill up with water. So that's out.
In what way do you think that question was sensible? I feel at this point you're just being frivolous.
I really don't see how this model can work.
And that's not our problem, it's yours, because it's not a model, it's reality.
Okay, here's my model. It's a scientific fact that water seeks its own level. That makes all the oceans flat. So here's Lake Victoria, and it drains down into the Mediterranean Sea right there. So let's place our little mock-up river on here. And we're basically going to pitch it 3/4 of a mile. Piece of cake.
Yes, a complete piece of cake. Well done you. Makes perfect sense on a flat Earth. Of course, what doesn't make sense that on the Gleason Flat Earth map, Africa is much smaller than it is in reality. So your River Nile doesn't even fit.
Obviously, if you survey it, it's going to be 3/4 of a mile higher on this side, and it's going to pitch down to the Mediterranean Sea. 3/4 of a mile. No problem. Okay, so here's the challenge. Make a mock-up of a globe with a circumference of 25,000 miles with the Nile River as stated that actually works. I would love to see it.
You're standing on one, mate. And I think you know full well that what you are asking for is impossible on Earth because of our old friend gravity. I've had enough of this challenge today. What do you all think? Do we think this is a fair challenge? Let me know in the comments. Right, well, there we go. Another Flat Earth Friday, all done and dusted for another week. I do hope you enjoyed it. If you did enjoy it, please do consider subscribing to the channel. As I always say, we're on the march to 500,000, just 45,000 to go. or it might be 44,000 by the time this video comes out. And of course, if you really enjoyed it, hit that like button too. Thank you so much for watching. It truly is appreciated. I've been Simon Dan. Have yourselves a great week, and I'll see you on Tuesday, where this time I will be responding to someone who's giving us an Astronomy 101 lesson. He's been waiting quite a while. See you then.